Hello guys, welcome you all for this end-to-end session on AIML, where you guys gonna learn everything that you guys need in order to become a successful data scientist. Hope you guys are enjoying, guys. So as always, like we have completed everything related to playing with data. Okay, like we have started with how to handle the data, where to collect the data, how to handle the data, what are the EDA that we need to do, like those things, and we have gone into something like programming code snippets and some query language code snippet, and then related to data, how to pre-process those code snippets we have seen, and we have entered into a new field. Like we are just exploring the machine learning thing. So yeah, we have completed nearly like 5+ algorithms together with this coding. Last session is all about like SVM coding session. So hope you guys are enjoying and you guys are learning a lot. So we are learning, we are enjoying every day, guys. Hope the same thing for you. If you guys stuck anywhere, if you guys have any doubt, just make sure like you just ping us in comment section. We will take up the doubts and we will solve it. Okay. So yeah, guys, without wasting any time, let us jump into this session. Before that, make sure you guys watch all the previous session videos so that you can have a continuation, and then also you can now able to see, able to understand what we are talking. Okay. So yeah, today is all about another algorithm in machine learning, that is KNN, K nearest neighbors algorithm. Okay. So K nearest neighbor is a simple yet a powerful supervised learning method used for both classification and regression tasks. It classifies new data points based on their similarities to the existing labeled data points. Okay. Guys, I will say compared to the previous steps, right? The previous algorithms we have seen, this KNN is quite, I will say it's quite simple, but it is powerful. Okay, it is also very useful for both classification and regression tasks. So in this, it will classify the new data points using its feature mapping to the existing feature. That's it. Hope you guys can understand. Simple thing, it will have an existing data set. What are the features there? In order to classify that, so it will look for the features whether it present in the new data, so that it classify to the category. Okay, so yeah, it's a simple and quite interesting algorithm, guys. Okay, yo, this is what about Kane. Yes sir, over to you. Yeah,
Yeah,
so I hope like, yeah, good sir.
yeah. So K nearest neighbors KNN algorithm. Okay, guys. Usually, if you see there's a meaning in the name. This algorithm is a powerful algorithm, simple, but it will always see nearest neighbor. By name, you need to observe. When you see the name, you can. A lot of times, algorithm name will not suggest what it is going to do, but most of the times you will see it suggests something. Okay, and the k nearest neighbor KNN is simply yet powerful supervised machine learning algorithm. Okay, you need to remember this part: supervised machine learning. Okay, used for both classification and regression tasks. Okay, it classifies new data point based on the similarity in existing labeled data points. Okay, so it will try to find nearest neighbor ultimately. That is what is the real behavior of k nearest neighbor. It will try to find the nearest neighbor. It has limitations, guys. Okay, and it has good advantages and disadvantages, which will go in deeper. So this is what it is, but go watch all the sessions. Don't come to this session. If you have come, go watch all the session 5 to 10 times. Absorb the information. Don't search on different places. Okay, keep simplicity. Focus. If you are at Noble Transformation Hub, you're with us. So be with us till you reach a goal. Don't have a scattered and what you call a non-sustained attention. Have sustained attention so that you achieve something. Don't keep surfing here and there or finding things here and there. Focus at one place so that You can build skills. So go watch all the sessions 5 to 10 times and absorb the information, digest the information, and apply. Do all the assignments. Okay. And what is your objective function long-term goal? And write in the comment section. Also give us feedback for these sessions, and also subscribe to our channels. Also press the bell icon so that you will get notification for each session. Don't miss it out. Have a long-term, lifelong learning vision for your learning, guys. Let's move to the other section.
Yeah, sure, sir. So moving on, let's see what we are having. Okay, let us understand this KNN. Guys, just come with me because like we're gonna see how this algorithm works. That is the black box of this algorithm. Let's see. So determine K, set the number of K nearest neighbor to consider. So you need to manually set how many K values for your data set. Next, calculate the distance. Calculate the distance between the new data point and all the existing labeled data points. So you need to find a K. Consider entire face, right? The entire picture that I'm having. Consider it's an environment. I'm gonna have a dot here. So this is what the K. I need to find the I have fixed a K. I need to find the distance between all the new data points whichever coming to this existing labeled data point. This is only one data point. Okay, now select the nearest neighbors. Identify the K nearest neighbor to a new data point. So for this point and for this new point, is this new point belongs to this point, that is whether it is closer to the existing point. So classify or predict. So for classification, assign the class label that occurs more frequently or most frequently along the K neighbors. Okay, it's a simple thing, guys. I will put it in a simple manner. We need to find number of Ks for our data set. Whatever the data point which is nearer to that K. For consider we are having 3 Ks, K1, K2, K3. Okay, and we are having nearly 5 data points. Okay, if the first 2 points are nearer to K1, then classify it to K1. If the second 2 points are nearer to K2, classify it to K2. Last point, if it is closer to K3, then move it to K3. Like that, it will understand and it will classify. Okay, we need to determine the K value. We need to find the distance between the new data point and the K value, and we need to map it so that we can classify it. Okay, hope you guys can understand. It's a very simple progress. So whenever K nearest neighbor comes to your mind, okay, we need to fix a K value and we need to find the distance between all the data points to the K value, and then we need to create a classification. That's it. Okay, hope you guys can understand. Yes, sir, over to you.
Yes. So, guys, understanding the KNN algorithm, we have 4 steps. Okay. First is determining the K. Okay. Set the number of nearest neighbors to consider K. Now you know K what it means. K means number of nearest neighbors to consider. Okay, that is K. I think this is now clear. What is K? Okay, now calculate the distance. Second, calculate the distance between the new data point and all existing labeled data points. Okay, so now you can relate why this is a supervised learning algorithm, because we are using labeled data points here. So everything suggests something, okay? So calculate the distance between. See, you can see by name the algorithm's behavior that it will look for the neighbors, nearest points, right? Data points. So calculate distance between the new data points. All exist labeled data points, okay? Then we have to, third step is select the nearest neighbors, which is identifying k nearest neighbors. See, k is itself number of nearest neighbors to consider. That's what set the number of nearest neighbors to consider k. But then it if you see third point, identifies k nearest neighbors to the new data points. Okay. Then we have to classify or predict. Okay. So what we'll do is for classification, assigning the class label that occurs most frequently among the k neighbors. And this is if you see, this is the behavior of a k nearest neighbor algorithm or characteristics. This is how it will behave, guys, when you're going to build model, okay, or you're using it for your project and all. So this is how it will behave overall. Just absorb the information, digest and apply. So you will be understand why and what and why. Okay, how you will, it will be a cakewalk, right? That's not a problem. But most difficult part is that people don't understand. They'll say, yes, yes, I understand. Actually, they don't. Okay. Actually, you have to understand what and why. Then it is cakewalk. Okay. Let's move to the other section.
Yeah, sure, sir. So guys, let's move to the next slide. Okay, choosing optimal k value. So I hope like now you guys will be having, this is the one of the doubt that you guys will be having, because like we are saying like k, how to find the k. Okay, let's see. First is impact of k. A lower k value can lead to overfitting, whereas the model is too sensitive to train data. So if you select a very low k value, that is 1 or 2, then it becomes overfitting, because what happens means the model start to learn, memorize the things. So that's the reason the model gets overfitting. Impact of k. Next, higher k value can lead to underfitting, where the model is too general and doesn't capture nuances of data. So when your k value is very low, it leads to overfitting. So it starts to memorize the data. When your k value is high, it becomes underfitting, because it is not at all gonna learn the training data itself. Next, cross validation. Use cross validation technique to find the optimal k value for the best model performance. The thing is, we are having something called as cross validation. Using that, what we can do means we can play with the combinations of value. Okay, I will say different combinations. So when we are having two data, right, based on you, I hope like if you guys are belongs to ECSE, sorry, EC department, you guys know about the gates. Okay, we will be having gates, right? So in like AND gate, OR gate, like those things, that there will be something called as a how to work on this, like cross validation. Okay, it is, it helps us. It's a technique that is used to find the optimal k value for the best model performance. Okay, so whenever the model is performing best, this cross validation is one of the things which is used to create a optimal k value. Okay, like it will go for a permutation combination, as I mentioned in the gates in the easy department. There will be like, if there are two inputs, there will be four different possibilities will be there. Okay, like true false, false true, false false, like that. Here this cross validation is a technique that is used to find the optimal k value by using multiple methods. Okay, multiple things, so that the model performance will be increased. Okay, finally, elbow method. It's a simple method. So plot model performance against different k values and observe the elbow point where the performance starts to like plateau. Okay, the thing is, you guys know, right? Over the time, the loss will reduce. From 100, the loss will start to reduce. The point where it create like bell like I will say elbow like structure, right? This like this, okay, like elbow like structure. You need to keep that as a k value. Number of k values you should keep by using that. Okay. Hope you guys can understand. So these are the choosing optimal parameters, like optimal number for neighbor. Okay, neighbors. Okay. Hope you guys can understand. So yes, sir, over to you.
Yes. So, guys, choosing the optimal number of neighbors, okay, in K. You know? So, impact. First is it has four, see, four elements gives us the optimality for neighbors of K, right? Ultimately, that is the objective, guys, for any model, any project to optimize. why AI is there, why we have created machine learning, deep learning AI to optimize the objective function. That is a single objective. So, impact of K, the lower the K value leads to overfitting because your model will learn too much. So you know what is overfitting. Like you eat a lot of food, you will feel lazy, you will not perform well. Same way, the model will not perform well. You need to remember this way. So where the model is too sensitive to the training data. That is what we are not building a model which is sensitive to the training data. We are just training it for what? For the actual performance, for the actual real life project, right? We are not training it for the data only. We are training this so that you learn that how, suppose somebody goes school till graduation or masters, they're just learning that how to behave, how to do this, how to skill sets, right? They're not learning that, oh, they will go out of the school or college or university, they start behaving like a student. That would be overfitting, right? They have to understand in their own conscious, own awareness, applying these ideas and these concepts in the real life. Same way model has to do the same way. So if you give him lot of learning and training data is sensitive to it, so it will not learn. That's it. It will say, "Oh, I've done. I don't have a real life to learn. I have learned from the university college. I know no learning in the real life and solving problems of real life. But we are building model to solve the real life problem, objective function. That is what we are building the model. That is why it is overfitting. Then higher the K value, what is the problem with that when higher the K value is that it leads to underfit because it the model is too general and doesn't capture the nuance of the data, like it's too generic. So one end it is too sensitive to the training data, that is overfitting. Then other end it is too general. Now what we need is we need a journal middle path. That is the concept for all models, guys. Middle path. You model has to choose the middle path so that it can learn and make decisions in real life projects. Okay, real life application, whatever objective function you have. So cross validation is the it gives the optimality for the model. So it uses cross validation technique to find the optimal k value for the best model. If you see, I smell something here, that is mean mode and baseline normal distribution. I smell here with cross validation, guys, because it is a balance of optimality. No, so it is normally distributed data, and it is normally distributed or learned model which is which is with negative and positive. It knows both the ends and then he solve the problem. That is why cross validation is very important. Then you have elbow method, which is plot the model performance against different k values, observe the elbow between where performance starts to. Okay, so this is what is all about, like when you choose the optimal number of neighbors in K. That is what I'll tell you. In life also you have to balance. When we say work-life balance, when we say you have to work, you have to do this, you have to do sports, you have to do exercise, you have to do meditation. That's what is balance, right? So neither you you keep working only, you don't sleep, you don't eat healthy food, that will be a one extreme, the other extreme. We need to have a balanced way. So that balance and middle path is also required in your model. So that awareness you can bring whenever you're building model. Think of building a balance and uh, a, a normally distributed model. Try that. It sometimes can be plus minus, that's okay, but that sense you need to have. That is why we use normal distribution. We understand skewness, positive, negative skewness in the data. We understand anomalies. We understand outliers. Okay, we understand all those aspects and concepts. So that is going to make sense. Okay, when you're building a balanced model, which is cross validation, which is uh, optimally optimized, okay, model which is going to learn and make decisions and optimize the particular project and application. Keep learning deeply, guys, with meta level understanding. Let's move to the other section.
Yeah, sure, sir. Yeah, moving on, like we're gonna see handling categorical and continuous features. I know you guys already know about it. Let's see how to handle this. Continuous feature use the distance metrics like Euclidean distance or Manhattan distance to measure the similarity. So whenever you have something called as a continuous features, how to like able to calculate this is just simple. You need to find the distance metrics like Euclidean distance, where or Manhattan distance to measure the similarity. So you need to find the similarity of each and every words in the document. For that, we can use this like Manhattan distance, and then something called as this Manhattan distance, right? This is one of the way of finding the distance. So to improve the similarity. So this is how continuous features works. Categorical features, it encodes categorical variables using uh, like techniques like one-hot encoding or ordinal encoding. There are multiple encoding available, guys. So this is how we can pack this categorical features. Then data scaling, scale further using technologies like standardization or normalization to ensure equal contribution from all features. Okay, so the thing is, you guys need to be very careful when handling this categorical and continuous features, because like for the continuous features you need to use something called as a distance formulas like Euclidean distance, Manhattan distance to find the similarity. Whereas when you are like working with the categorical features, you need to go for encoding kind of thing, like one hot encoding, ordinal encoding, or normal encoding, like those things you need to do. For data scaling, it's a feature that is used to that like standardization and normalization to ensure equal contribution from all the features. Yeah, because like if the data is biased, right, if it is left or right skewed, then it's not going to be work. So we need to somehow fix it. Okay, so yeah, for that we are using something called as data scaling here. Okay, so how to handle the data in like KNN, like KNS neighbor continuous features, how we can handle it means by using the distance formula. Categorical features, but we need to use like one hot encoding and ordinal encoding. And for data scaling, so it is one of the powerful thing. Okay, it ensures equal contribution from all the features. Okay, so yeah, this is what all about handling categorical and continuous features. Yes, sir, over to you.
Yeah, handling categorical and continuous features. So, guys, you also know that we have two kind of problem. One is categorical, the other one is continuous. Okay, so this is what we have to understand. Handling that, those features. So, continuous features using distance matrix like Euclidean distance or Manhattan distance to measure the similarities. So you will understand Euclidean distance is again a mathematical function. It's a and Manhattan distance is also. So right now just absorb it. No need to worry about what it is, how it works. So just understand it. Then we have categorical features and encodes categorical variable using techniques like one hot coding or ordinal coding. Again, this is we do one hot coding, okay, Again, this is a very simple, it's a one-liner, two-liner program. You don't have to worry. So this is very simple. Just remember these terminologies. And then we have data scaling, scale features using the techniques like standardization, normalization. See, guys, I told you before we started this session that it's all about that normalization, standardization. You need to be well equipped with the stat and the techniques and concepts. Okay, so equal distribution for all features. Then and only your model is going to learn. If it bias, it will do. If it is biased, overfitting, underfitting, outlier, anomalies, all these things will be there. That is why pre-processing is very important. That is why data from the right source is very important. That is why choosing right model is very important, so that you can train well and build great models, guys. So this is the essence of, I'll say, I'll give credit, 90% credit to what and why. So once you understand what and why, application is nothing. You can do, and there are tools, like you don't need to, you just need to know how to use the libraries and tools. That's it. So the game is, a lot of people get stuck into how. I want to build this. I want to, without knowing what and why. So 90% weightage I give what and why. So once that is clear, how is nothing. Keep learning deeply with persistency, consistency, and patience. Let's move to the other section.
Yeah, sir, sure. So, guys, hope like yeah, this is what all about today's session. Okay, so we have introduced you to the new algorithm called as KNN and what are the features that it is having, and we have seen how we are calculating this KNN. Then finally, we have seen about the categorical and continuous features. Yeah, so this is all about today's session, guys. Hope you guys have enjoyed a lot. So today we have covered a part of theory session related to KNN, and we will be continuing in the next session the theoretical part, and the next session we will have the coding, okay, for this KNN. Hope you guys are enjoying. So if you guys have any doubts, just ping in the comment section. We will take up and solve your doubts. And yeah, so that's one thing. And guys, if you guys till now doesn't subscribe to our channel, please subscribe to our channel so that you can get the videos whenever we are posting. So yeah, this is all about this session. So yeah, guys, until we all meet in the next session. Thank you, guys. Take care. We will all see you. We will all meet in the next session. See you guys. Bye.
Take care, keep learning deeply. Thanks. Thanks a lot.